In lesson 3.5, we're going to be talking about the slopes of lines. And the topic of slope should be a review topic from your middle school math and also from Algebra 1. I'll remind you that when we talk about slope, a lot of times we represent that with the lowercase letter m. And also that the slope describes the steepness of any line. When you're talking about slope, you can use any 2 points on your line to determine the slope. And we define that the rise is the difference between the y values of the 2 points on the line. And so we look at rise as being y2 minus y1, really the difference in the vertical change. And the run is the difference in the x values of the points on the line, x2 minus x1, the horizontal change. And so when we look over here at our diagram, I have the 2 points that they're using, and when they look at finding their rise over their run to find their slope, graphically we could just count those boxes to find the slope. But it is the ratio of rise to run, or rise over run. Algebraically, the formula is going to look as m equal to y2 minus y1 over x2 minus x1. Here I can see that my slope, rise over run, was 6 over 4, but we always want to make sure that we reduce that fraction. So look down below in example A, we're going to find the slope of our graph. And here, remember, we can use any 2 points on my graph. So I don't have to pick the points J and K, but because those are exact, looks like those would be the easiest points to use. If I look at my rise over my run, I'm going up, I'm going over. I'm simply going to look at how many boxes that is. So we're counting 1, 2, 3, 4, 5, and run 1, 2, 3, 4. And so my slope for the line JK is going to be 5 over 4. Now, this is a positive slope, 5/4, and we really wouldn't write that as 1 and 1/4 because we are wanting a ratio comparing 2 numbers. Okay. Our slope for number 2, well, rise over run, I can first tell you that because going left to right, this is going downhill, it's going to be a negative slope. If I'm going to use my points L and N, I'm looking here, I'm going to drop rise over run, counting my boxes, 1, 2, 3, 4, 5, 6. Going down, I have a negative 6. I'm going over 3. I'm going to denote this slope as negative 6 over 3. I do like it to be reduced, and so we're going to say negative 2 over 1, which we could write as a slope of negative 2. In example B, I do not have my graph. I simply have the coordinates of my 2 points, and so I'm going to solve it algebraically by using the formula above. And so we're going to look at taking y2 minus y1 over x2 minus x1. We know from earlier in the year, as we talked, that typically our first point we denote as x1, y1, our second point as x2, y2. So if I were to substitute in my numbers, I am going to be taking negative 5 minus negative 2 over negative 3 minus 6. We want to be careful here. We have a lot of negatives or minus signs to work with. Doing a little bit of simplifying, I can think about that as adding the opposite or adding the opposite. Simplest form here? Well, negative 5 plus 2 is going to give me a negative 3. Negative 3 plus negative 6 is a negative 9. We know that a negative over negative is positive, so this slope we're going to refer to the ratio as 1/3. Substituting the values in for my second slope, y2 minus y1, x2 minus x1. I am going to think about adding my opposites. 2 plus 3, negative 6 plus negative 8. So again, I have 5 over negative 14. The overall slope is a negative value. Just because the negative is on the bottom doesn't really change my slope. Some textbooks would just put the negative up front, as so. They both mean the same thing. Okay, turning to the back of the page, at the top we have a chart that's just reminding us that when we think about a positive slope, we're really thinking about as we move left to right, we're going uphill. Or a negative slope as we move left to right, it's going downhill. We know that a horizontal line has a 0 slope. There is no rise over run change. And looking at a vertical line, the slope is undefined. And as you see in the top, it's undefined because it is impossible to divide by 0. Our slope refers to our rate of change. When we take a look at parallel lines, well, parallel lines, we know they never intersect. So if parallel lines never intersect, what does that mean about their slopes? Well, it may be a little bit hard to see in this picture, but if we looked at rise over 1, we can see that both of them, 2 over 1 and 2 over 1. So in order for lines to be parallel, they must have the same slope. Even if they're slightly different, the lines are not going to be parallel. Eventually, they would intersect. Perpendicular lines, we know that perpendicular lines meet at 90 degrees. Well, what's true about them if we were to graph them and we were to take a look at their slopes? Here, I can see that this slope, positive, 3 over 2. This slope would be negative, and I see negative 2 over 3. Well, two non-vertical lines are perpendicular if and only if the product of their slopes is negative 1. What does that mean? Well, in other words, the slopes are going to be opposite reciprocals. You may also hear that stated as multiplicative inverse. And so they give us the example, 3 over 2 and negative 2 over 3 are opposite reciprocals. One's positive, one's negative, and the numbers are reciprocals of each other. It also states that vertical lines and horizontal lines must be perpendicular. So in example C, they're asking us to determine if our two lines are parallel, perpendicular, or neither. And I can see that in the first group, they're wanting me to look at the line UV compared to the line XY. So here, my line UV, here is my line XY. I really need to take a look at their slopes. So we're going to go ahead and calculate their slopes with our formula. We're going to use the y2 minus y1 over x2 minus x1. So first I'm going to take a look at my line for UV. or my slope for UV, excuse me. Looks like we would have negative 1 minus 2 over negative 1 minus 0. Negative 3 over a negative 1. The slope is going to be 3. I'm going to look at my second slope for xy. 3 minus 1 over negative 3 minus 3. 2 over negative 6, which is going to give me a negative 1/3. If we compare our two slopes, 3 and negative 1/3, I can see, yes, those are opposite reciprocals. One's positive and one's negative, and 3 and 1/3 are reciprocals of each other. And so these two lines are going to be perpendicular. If I take a look at the second one, I am comparing line CD and line EF. Four over 2, I can see that the slope is 2. And 2 over 1, the slope also comes out as 2. 2 and 2, the slopes are exactly the same. That must tell me that these lines are parallel. Now, even if my slopes would be almost the same, for example, if one was 2 and one was negative 2, that actually would be a neither. They wouldn't be parallel, they're not identical, and they wouldn't quite be, they're not opposite reciprocals. And so in the case where you get two slopes that are unrelated, you're just going to say neither. Really what that means is that those lines are going to eventually be intersecting. If you have more questions on slope, please stop in and see me. You can also check out the other online videos that are sponsored from our textbook.